Hello, I want to go over our objective for today. So hopefully in the next 15 minutes or so, we will be able to do these two things. Determine the number of solutions to a system of linear equations, and can we solve a system of equations by graphing? So you should have a notebook there, and I'm going to need you to open that up to page 387. Now we're just going to go over some vocabulary here. You don't need to write anything, but you may want to circle or underline some important terms here. So a system of equations is anytime we're trying to solve more than one equation at a time. And there are some different things that can happen when we do that. So anytime a system of equations has at least one solution, we call it consistent. You should find that in your notebook. You might want to, like I said, underline, circle those words, highlight them. So if they have a solution, we call it consistent. Now, it can have different types of solutions. When a system has exactly one solution, we call it independent. If it has more than one solution, then that means it's going to have an infinite number, and then we call it dependent. So if it's consistent, if it has a solution, independent if it's only one, dependent if it's more than one. Now, it is also possible that a system of equations has no solution, no ordered pair that works. We call that inconsistent. So no solution would be inconsistent. So find this graph at the bottom of page 387, and you will notice that these two lines cross each other. That intersection point is the solution to this system of equations. So we would say that this system of equations is consistent. And since they only cross each other one time, we would say it's independent. Go ahead and circle those two. And from that graph, I can actually see what the solution is. It is that ordered pair that I highlighted. 1, -2 would actually be the solution to that system of equations. All right, so find this graph on page 388. Now you'll notice we've graphed two lines here. They happen to be parallel lines. Parallel lines never touch each other. And it's the intersection point of my lines that determines my solution. So if they never touch each other, that means these are not going to have a solution. So if there's no solution here, we would say that this system of equations is inconsistent. All right, we have no solution because my lines never touch each other. This is inconsistent. So you got a couple more examples here that we can see here. So I can see the one on the left. This is right in the middle of page 388. The one on the left, again, I have two parallel lines. We would call this system inconsistent. Has no solution. Or the one right next to it, we would call that consistent. Consistent means my lines definitely hit each other. And we would call it independent because the lines only touch each other one time. So those are consistent and independent. Now, you should really be able to tell what's going to happen based off just the equation. So now we're going to try that without seeing the graph of the equation. Look at the ones that happen to be parallel to each other. Remember, parallel lines have the same slope. Well, if I look at this graph, I'll notice that the equations have the same slope. Remember, the slope is the number in front of x. So when I look at the number that comes in front of x in the blue line, I can see that. Let me get us back on track here. I can see that the slope of those two lines is the same. Notice -1/2 and -1/2. So based on the fact that they have the same slope, but not the same y-intercept, I know those two lines are going to be parallel to one another. So let's try that if we don't have a graph to look at. Look at these two equations. They both have a slope of 6. I remember the number in front of x. So the same slope, but notice the y-intercept is different. What that tells me is these two lines are parallel, which means they will never cross each other. That system is inconsistent. So you've got some blanks at the bottom of page 388. You can go ahead and fill those in. These lines are parallel to each other, which means they will never have the same slope. If they had different slopes, then I know they have to touch each other at some point. So if I were to change the slope of one of these equations to a different number, anything other than 6, what that means is, let's pretend this is a 5. Different slopes mean they have to touch each other at least once. This system of equations would have a solution. Now, the other thing we want to be able to do today is, can you actually solve a system by graphing? So we're going to do that next. So I want you to turn to page 390 and find the example at the top of that page. So what we want to do is we want to solve this system of equations, and we want to solve it by graphing. So again, this is at the top of page 390. You can see the graph here already. You don't have the graph on yours. But let's go over, how did they come up with this graph? Notice these are written in slope-intercept form. These should be pretty easy to graph when they're written in this form. Remember, we're going to start at 14 because that's my y-intercept. So you can see I have a dot at 14. And then my slope is -2, which I'm going to think of as -2/1. So from this point, they went down 2, right 1, down 2, right 1. They came up with that line right there. Now they're going to graph the second one. Well, where did they start? They started at the y-intercept, which is 1. Notice they're counting by 2's here. So there's 1, and then the slope is 3/5, which means they counted up 3 squares and right 5 squares. They drew a line between those two. These two lines obviously intersect each other. They cross each other. That intersection point tells me what the solution to this system of equations is. So the solution to this system of equations is that point where they cross each other right there, which would be the ordered pair 5, 4. That is the solution to this system of equations. So let's try one more of those. Look at the example right below that one. So right in the middle of page 390, this time the graph's not there for you. We have to graph these. And notice they did not give these to you in slope-intercept form. So we want to rewrite these so that they are in slope-intercept form. So I'm going to rewrite that top equation. Remember, there's 2 steps to doing this. First step is move the x to the other side. So I'm going to end up with 5y is equal to -3x plus 10. So I just moved my 3x over, but I made it negative. Now I have to divide everything by 5 to get y by itself. Divide by 5. So I end up with y on this side. -3 divided by 5 is not going to work out very well, so I'm just going to leave it as a fraction. -3/5 x. 10 divided by 5 works out pretty good. 10 divided by 5 is going to be 2. So go ahead and put that in your notebook. We rewrote that one. Now I'm going to rewrite the second one. Again, I need to move the x to the other side. So that will be my first step. So I'll end up with -5y equals -x. And remember, that's really like a -1x minus 10. Now if I divide everything by -5, divide by -5, the 5's will cancel. That's what I wanted, y by itself. 1 divided by 5 doesn't work out very good again, so I'm just going to think of that as 1/5 x. And then negative 10 divided by negative 5, that works out okay. That's positive 2. Well, now I have two equations that I should be able to graph here. So I want to graph these two equations. Again, I'm looking at them in slope-intercept form. That makes them a little bit easier to graph because now I know I'm going to start at 2, right? Let's graph the top equation, this one right here. I'm going to start at 2. 2 is right here, and it has a slope of negative 3/5. So count down 3, right 5, and I'm going to draw a line through those 2 points. All right, now I'm going to go to the second one. That one also starts at 2, and I'm going to go up 1, right 5. I draw a line through those 2 points. Well, they both have the y-intercept, so where did they happen to cross each other? Right there. That is the solution to that system of equations. They cross each other at 0, 2. 0, 2 would be the solution to that system of equations. So we should end up with a graph that looks kind of like that. Go ahead and put that in your notebook. And then as we're doing the assignment today, remember to refer back to your notes. If you don't remember what consistent means, look at your notes. If you don't remember what inconsistent is, look at your notes. If you need an example of how to graph a system of equations, you have a couple examples there that you can use when working on today's assignment.